Coming together is a beginning, keeping together is a progress, and working together is a success. A very good evening to all the guests and dignitaries. With great joy and immense excitation, I feel privileged to extend my warm welcome to all of you for today's webinar on how to start a career as a data scientist, organized by Digisaksham. I, Kanika Garg, welcome you all on behalf of Digisaksham. Before I proceed, let me take a brief moment for the introduction of my organization. Digisaksham is an initiative of SEMS Group, which has developed content over 300 courses in multiple languages, which range from 4 hours to 6 months in various sectors of IT, BFSI, retail, entrepreneurship for all the age group, from school children, youth, professional, and even the senior citizens. Digisaksham also conducted more than 100 webinars, 10 FDPs and workshops, 6 international conferences. Digisaksham impacted more than 15,000 plus lives through various webinars, conferences, workshops, seminars across the globe. The topic for today's workshop is how to start a career as a data scientist, which is presented by Mr. Aqib Javed Khan sir. A data scientist is someone who practices data science to analyze data so that they can provide actionable insight by various processes, methods, system, and algorithm. A data scientist is a highly qualified professional with highly developed mathematical, statistical, scientific, analytical, and technical skill who can prepare and validate structured and unstructured data for business to use to make better decisions. Now, I profusely elated to take an opportunity to introduce our chief guest of the day, Mr. Aqib Javed Khan sir. He is a scientist with almost 5 years of experience holding a strong understanding of online consumer space. In his recent year, he has been working on information building, large-scale search and ranking system. He gained experience in LLP utilizing cutting-edge algorithm to solve business problem. Now, the world is full of diamond and gem, and we are having one of them here today to build this event. With this note, I would like to heartiest welcome to our keynote speaker, Mr. Aqib Javed Khan sir, with a big round of applause.
Thank you, Kanika. Thank you for the brief introduction. Let me start with this. First of all, thank you very much for everyone who joined in the weekend on Sunday. So, and today I'm going to talk about how do you start a career as data scientist, what you actually work on. So, brief about me in more detail is like, 5 years experience, mostly into the consumer space, but I worked in the e-commerce and financial organization, the two of the main vertical, I'd say. In this, and apart from that, also there are a few other companies which I changed, and that was not exactly into the vertical, but there are different kind of problems we are solving. So I can talk about the variations of problems that how we actually how we see and how it is solving the problem for our customers, or like depending on any kind of business problem we are trying to solve. In this, like I mostly work into 60 to 70%, I would say NLP, natural language processing. That's my subject. I can say like bit of expertise. I gained bit of expertise in that, especially in building the search systems and the ranking algorithms, working on those things. So and also in the like 30 to 40% in the computer vision. So mostly like in computer vision, when you have the images, so you can leverage that data like to build a better search engine, or like as nowadays you can like use the your app or shopping app to just like click the image and you'll get the similar images. So those things I have already worked on that. Like I think 3 years back, our team we were working in that, and we put into the production. That was quite impressive actually. It worked quite good. So yeah, I can talk about all those things. So yeah, let me start. And first and foremost, you really can't start a career directly as a data scientist. Let me tell you that this is really a fact. Like if you're a fresher out of college and you really want this title, that's not possible. Even if you're a software engineer and you really want to get this title, you can't get it. It's even as having 5 years experience, I usually don't say that I'm a data scientist. I'm a bit afraid of that. There's so many things to learn and implement. A data scientist is really a big, I'd say, very big field, and it's a very, very big responsibility. So it's very difficult to become a data scientist, a full-fledged data scientist, because in that you really need like a lot of expertise in different kind of, uh, technical expertise you need on a different verticals, from like mathematics, like from mathematics to programming to business understanding, everything. It's hard actually to be a data scientist. It sounds cool, but it's not. Let me tell you that. Yeah, okay. And then, okay, that's why I just wanted to have this first slide. So don't, if you're thinking that you'll do some kind of a course, like it give you 3 months or 6 months and you'll become a data scientist, it's a bit difficult. Okay. Yeah, so let me just define what is data science. It's so as you like you might be knowing about, like, we always play with the numbers, different kind of data. Actually, we play with the data and we try to solve one kind of problem. In any industry, let's say if you're in insurance, you're trying to figure out, like if you want to give the insurance or not. In banking, if you want to give how much credit, or like if you want to pass the loan or not. In e-commerce, mostly you like basically you try to increase the CVR conversion rate, click-through rates. There are many different kind of problems you try to, like, NLP, natural language processing, where translation problem, uh, text generation problem. So there are like all different thing, and this everything comes under, like, data science. So it's very, very difficult to like have everything, or like learn everything in that. So there are like, so we can categorize data science into like few subsections. Like first is like, you see the machine learning, data mining, statistical inference, and visualization. So these are like different verticals, like where you actually work. And if I'm speaking fast, please let me know. So if you face any problem, just let me know. So here, like what we do basically in data science, we always, like, we start with a problem. First we have to figure out, okay, if this is a problem or not, like, and you also have to decide whether this problem you're going to solve, how much ROI it is giving. So like whatever you implement, you can implement the very coolest thing, but what is the return of investment? So before implementing anything, and you have to take care, you have to design the solution like that, so that it can sustain your, like, sustain your organization. Like if you are putting anything in a production, and if it is costing you more than what you are getting from that, that's not feasible. You can't just have one feature on the state of the art sort of thing, and you really can't put into production because it looks cool. I mean, you have to have some kind of a revenue. Either you are trying to generate more revenue, or you want to save something, or like cost cutting, something like that. So that's like the business thing. First you have to think about that, whenever you try to solve the problem. There is like another field called data mining. Usually I'll come to that part, but it's on like overall, you can see there's a database statistics, machine learning, visualization. These are the like overall things, like which you find in any data science, in any organization, what data science team does actually. So there will be one team who will do all kind of research on the like modeling part with the data, how you can figure out. There will be team like analyst who will initially take the data. They will find some kind of insight, and then they will generate reports usually. So mostly into the financial organizations, you'll see the mostly people in data science, what they do is basically take the data, they do visualization, and they will create the insight, and then create the report, and then show it to the stakeholders, like what is going up, what's going down. So you actually find all those details from the data. You'll try to basically find the pattern in the data, like how it is going, how your customers are behaving, and then like you take certain decisions based on those insights. And there will be a team of data science who actually take the model, so take the data, create the model for the predictive analysis. Or it really depends on like kind of problem. Like for example, let's say credit scoring. Like loan, if you have to take a decision on loan, like automatic, how you can make that. Then there is one very famous, and one of the hard problem is like fraud detection in the financial organization. So these people, take that data, and then they process it. They do a lot of feature engineering, and they build a model over that. And so there are a lot of model experimentation has been done. And so that data science team does that exactly. After that, there will be a team like who will put that model into the production. I mean, there will be a testing. Even the data science team do their testing on their own data set, but usually in big organizations, basically you have another team which the data they will have, you will have no idea of like what kind of like what the data is coming from, like from where, but it will be similar to the what you have modeled, and they will test on their own data set and see the performance. Because like as a data scientist, as a modeler, you're building a model and you will be a bit biased toward your model. That happens, like it's natural. I believe it's a natural, it's bias. Whatever you're working on, you feel like, yeah, this will work good. So this should like go into production. You have this kind of biasness, but as an organization, we really have to test all those things, whether it is working perfectly or not. So there will be another team who will do all this kind of thing, testing, and if everything goes well, they'll put into production. And to putting into the production is very hard. Like putting data science models, like especially deep learning models, putting into the production is very, very tough. There are like services which you can use to basically put the models into the production if you have to really scale. So I'll come to all those part, like the scalability and other things. In the meantime, you can also like note down your question or just put into the chat box. So that's the other team. So they will do it, and then there is a other team who will be like utilizing those APIs or like your model, and then take the decision for that. So you on a high level, this is how like a data science team basically works there. Okay, so let's talk about like in data science, like how many kind of roles you have. There are actually quite a lot. But this one I found to be very, I'd say, on an abstract level. As a data scientist, like you will work on a different kind of role depending on the different kind of organization you will get. So in data science, basically you have this main three. One is data scientist, data engineer, and data analyst. So as I told you, like data analyst people, they take the data, they do some kind of manipulation, and they'll basically try to generate the report. They try to get kind of an insight from the data. I mean, that's the main job. And they take the decisions. The stakeholders takes the decision from that data insight which you will give. The data scientists give. So it's mostly the job is about the data wrangling. They take the data. It could be like very messy data, and they have to go through creating kind of a report, or like a generate report, giving some insight. So it's mostly about they will not do anything like kind of modeling and all. There will be a bit small modeling they can do, but usually data analysts, they don't do this kind of. They do some statistical inference and all to basically have the hypothesis, and then giving like that hypothesis to be like what it is and what you are going to get with that data. So this is what data analysts do. Data engineers, they are actually they're great. Actually, they actually manage. They create the flow of a data in the organization, like how the data flows, even like the collecting data, organizing in such a way that anyone can leverage that data. So creating all those pipelines, that is amazing. Like that, you will really love. Like you can get bored with one of the data scientist job, but never with the data engineer in data engineering. This like flow of data from collecting to giving to some other APIs, like some other team. So you will create. So as a data engineer, you actually manage the whole data of the organization, like from where it is coming to where it's going, who is going to use everything that you have to. And data engineering is like is an awesome field. Amazing, actually. So here you learn about like mostly big data technologies. You have to work with the Spark. There are a lot of things like Scala programming language is widely used. Scripting languages, other Python and all. So you use to create the data flow. Yeah. So this is a brief about data engineers. They are quite good, and they always. So in an organization, it can be possible that data scientists are not needed at a time, but data engineer is important, because first you have to make sure that the data flow is right in the organization. Then in a data scientist, you actually get different kind of role. You can get machine learning engineer, deep learning engineer, NLP engineer. So depending on what kind of that company, what it is working on, what is their field. If there is a text, like some kind of a text generation, or some company which does play with the text, so you will get like NLP. You'll have the title like data scientist, but you are an NLP engineer or something like that. In an e-commerce, as a data scientist, you can work in a price, let's say in a price recommendation to product recommendation to search. There are a lot of like other things in the e-commerce. Like in just one, I'm giving just one example of the e-commerce, like where you'll have the title data scientist, but you will work on a different kind of roles depending on the business. Yeah, and I'll come into this in more detail later. So here I'm going to talk about the data scientist. Who are they? And as I told you, like what they do, basically they play with the data. They usually try to build some kind of predictive model, or some kind of modeling they do basically with the data. So we play with algorithms, like a lot of algorithms, like we try to find what is the best algorithm for this problem or this kind of data. That is that's what we do, basically take the data from the database or from anywhere, and we create the features, feature engineering that's called, and then we try to model that and we test it, then we try to put into the production if that actually solving the problem, and if it is enough to put into the production, you have to do all those calculations. So the roles you'll find, as I told, like machine learning engineer, NLP, computer vision, sometimes data scientists, like in mostly into the financial organization, in data science or data scientists, they are also usually you'll find analysts. So and general term analyst, and you will do all these things. Yeah. So for being a data scientist, or like depending on like what kind of problem you're solving, the kind of role you have. So there are some certain skills which you have to like know, or like, and you can master few of them. I really like so mathematics, statistics, this is like general, everyone knows that you really need it. And then machine learning algorithm, conventional machine learning algorithms, data analytics and visualization, because you actually first have to do EDA, like whatever you work doesn't depend on the kind of a data you're working on, either images, audio, numerical data, tabular data, like numerical data, anything. You have to do the EDA. So you have to know bit of a visualization tools, or visualization libraries, which you can utilize them to basically have some kind of exploratory data analysis. Then from there, you actually come to know, okay, if the data is imbalanced or not, then what kind of algorithm you have to use, what is the fine tuning you need to do on that. So based on your exploratory data analysis, you actually choose what to do. Okay. And then the one skill which I would highly recommend people to master is the programming one. Mostly people, they don't they usually see data scientists as mostly into the deep learning algorithms and mathematics and all, but you have to have very good knowledge of programming language, especially into the data structures and algorithms. So many people, like, they really ask me, is that important or not, like having these algorithms and data structures, is that important? I would say it's heavily, because when you work, whenever you write something, don't become I would say, don't be a model.fit data scientist. So there is if you see like 5 years back, when we started, at that time this was not very quite famous, I would say. People usually transform the data, and then just like, from at that time, mostly scikit-learn was quite heavily famous and heavily used, like even 5 to 8 years back. And basically you have to like transform it, and not whenever, but whenever you start doing this is good. Like, at least you will have some kind of a, that will have your spirit alive, that okay, you something is working on, and then but so at some point of time in your career, you really have to dig deep, and like how these things work. So if you don't know like programming, and if you're not aware with the data structures or algorithms things, it will be quite difficult for you to understand the code, because uh, when you actually productionize things, so you have to actually write production level code, and those things you have to make it efficient. One example I'll give, like if you like when you load the data, what in any project when you start, so you have to do some kind of data manipulation. You have to read the data, process the data, and if you don't know the basic like kind of algorithms where it can help you with certain things, that's going to take a lot of time, and there your code may get it take quite long time. So you have to know about all these things, and I recommend everyone to really practice on lead code or HackerRank, HackerEarth, wherever, but you need to, and you have to master this programming, any kind of this computer science skills. You really need it. Apart from all this mathematics and this deep learning, machine learning, you can know the deep learning different, like many complex algorithms, but if you don't know how to code it up, you will not be able to actually contribute. So yeah, programming, having the good understanding of algorithm is must, I would say, because this takes quite a lot of time. You can't master all these things in a month or like 20 days or something like that. No, at least it will take you 6 months. For sure, that's going to take you 6 months. Even if you do one or two questions on practice on a lead code or anywhere, it is going to take you 6 months. And why this is important, because like if you uh, I have gone through the very like few company interview, the big company interview. So they definitely ask you this kind of like questions from there, like medium level elite code questions, and don't get like have that impression that you're a data scientist and you will get only questions from the mathematics or something like that. The first level to the interview, the first level is always on the problem solving, and that will be the coding questions. So one day you have to actually go through it, so why not to learn from the beginning? So you start studying everything, statistics, machine learning, deep learning, whatever in this field, but programming is a thing like you have to practice all the time. So a very very important here. That's why I put it in the bold and in the bottom. So yeah, for any big companies, if you go, you have to code it up and try to implement all these things like from linked list to trees, like whatever, and try to whenever you, or the best will be like whenever you implement something, when you learn like from the, let's say, scikit-learn any model, let's say decision tree or something like that, or svm, try to just code it up, using the numpy. Don't use the library, or just try to just code it up, and then you will have a good understanding how things work, because ultimately you have to work on a very huge code basis. There will be code bases which you have to look into it, you have to add features in that. So there will be like a lot of things. You have to test the modules, you have to write your own test models, unit test, and all those things. So yeah, that's why programming is important, a must skill, I'd say. Okay, here I'll talk about the data engineers, what they do. So as I told briefly, they are mostly responsible for the data flow in the organization. Here actually you have to have all the knowledge of big data technologies, usually like from the databases, cloud. Mostly now you see all the big organizations, or like anyone, not even big, like any medium size organization, they started using the cloud, because that's very fast. You can use it. There are a lot of services which you don't have to reinvent the wheel, we say. So you can use all those things to utilize that. So, and what they do is basically using these technologies, they try to actually make the data flow as much smooth as it can. So because if you see in the any e-commerce, like when there is I would say when there is any sale or something like that, so you have to have make a reading from the database, putting the database, everything should be very very quick. The scalability is very very important. Otherwise your services will go down and conversion will not be happen, and then uh, people who wanted to buy, they won't be able to buy. You will not be able to actually get the revenue. So yeah, to make this we use these data engineers. What they try to do is just to make the data flow very smooth. Here also you really need a good programming skill. For sure, this programming skill, like you really need it like everywhere. One of the scripting language you can use, like Python, Golang, not Golang, but Golang is also good for backend, but Scala, and also you really need this kind of good command over that. Cloud technologies, big data, SQL, and there are quite a lot. I can't put like everything here, but these are the main thing. You have to know about the databases. Let's say NoSQL, SQL structured. Like it really depends on what kind of data you have, and then you have to choose the kind of database. So these are the must thing like you really need. And in the diagram you can see like how much a data engineer, like where they actually need. So you see this. Sometimes they actually do take care of the ML deployment. So ML deployment is one of the another. Another different field. So in the last 2 to 3 years, what I have seen, there is another field called ML ops. So there is something called DevOps. This is ML ops. So they have to actually take care of machine learning models, or like the processes, the machine learning processes, or data science processes, like how you can make them much faster, and you can use the iterative process. This how you can actually make the experimentation faster, because whenever we do the experiment, it's like if you are not saving all those matrices or anything like that, uh, you have to track down like what you have done previously, like 5 experiment, and then you have to compare with everything, and then you will choose which model, like what to use it. So to handle all those things, it sounds easy that you can do experiment and you will remember everything you do in a notebook. That's a very unstructured way to do any experiment, but you really have to have the version of everything, your data version, like what kind of data you have used, what kind of features you have used, and then you try to model that and see the performances, that you change something in the parameters, hyperparameters in the model, and you see okay, how it is behaving on what kind of data. So all this kind of permutations, or let's say this kind of combination you have to have a track of your experiments. And these ML ops, they do like everything from this like experimentation to putting models into the production. These systems, the people who work in ML ops, they actually use this kind of they create these tools. So one very famous is like you can use, I forgot the name of that. Well, okay, if it crossed my mind, I'll definitely again will tell you about that one. But yeah, this MLOps is also very important. It's a new field, I would say, fairly new field, I would say, from the in the data science. So because they take care of this deployment, or because you can actually, as a data scientist, you can create a very heavy model and you will not be able to productionize it, and that will really hurt you a lot. Like you're working on something for 2 months and then you thought, oh, this is very cool model, and on your test data it is performing very well, and you do the calculation that if you put into the production you will get this much like revenue or this engagement or whatever you think. But until you put into the production and if it is not able to handle those many requests and then you have to decommission that service, that's going to hurt you. So that's why you have to, when you start working on a problem, you have to think like from all the different perspective. Yeah, and also here, as you can see, like the business understanding is not much required, I would say, because it's more on a technical. Yeah, you will have that kind of a budget, like we can use this service, this one, because ultimately you have to go, your company or like your organization is going to pay for that, so you have to take care of that part, but not much. Mostly into the when you create us any budget, like this much budget you have, then you decide, okay, what kind of services we can use. It depends on that, but not very much business understanding here. Mostly into the data science, you really need a business understanding. Most of the data scientists who directly work into the computer vision or NLP, they thought like we can use this model or anything and this will solve the problem, but we have to understand the business understanding as well. So maybe something like simple, or I'd say simpler models, light models can perform very same. Like let's say one of the model, deep learning model, is giving you, let's say, 85% accuracy, and the another is like giving XGBoost or let's say random forest, it's giving you 80 or 82% accuracy. Then if you want, like, which model actually you're going to put into the production? Okay, I'm asking question now because I'm talking for at least I think 20-25 minutes now. Now it's your turn. Anyone, which model you will actually choose to move forward with? One is deep learning with 85%, and there is random forest and XGBoost with 80, 82. Okay, it also like depends. If that 3 or 4% doesn't make difference, you will definitely use that because those are very fast and not expensive, because putting deep learning models into the production is quite expensive. So you might have to use GPU if it is a service used by let's say consumer or directly users. It's like a continuously coming, let's say you're putting something in the e-commerce and it has to go through that, so you have to put it to GPU, and that if your model is running on GPU, let's say quite 24/7, let's say just for example 24/7, that is going to cost you a lot. And if you see from there the revenue is not that much you are generating, so you can actually discard that model and put something like which can run on CPU, like inexpensive machine. You can use that simpler models over there. So yeah, it depends on the business context. So yeah, that's the bit kind of difference in the data scientist and data engineers. So I hope you're now clear what they both do. And now we'll talk about the last one, which is data analyst. So data analysts are, as I told in the beginning, that they are mostly into the just getting the data, and they will try to also do a bit of feature engineering, and they will do the analysis of the data. That's the EDA. Like they will do the extensively data exploration, data analysis they will do, and they will basically come with a disease. Like they will give you, they are mostly they work with very closely with the stakeholders, or like could be a product manager or anybody, and they basically show, okay, this is the pattern which any of the services is showing. Okay, and if we do something, if we change something, this is going to impact our business, or like anything. Let's say for example, showing an ad on the website, and you know that this mostly people are active from, let's say, 10 in the morning to 7 in the evening, and in the night usually people don't go. So, and if let's say that there is a service which is quite expensive which you are using, and you want to add there, and then you have to show it, and your data analyst says that, okay, why we are running, if these ads are very important, we should run on this time, and maybe this day of the week where the people's comes. So you from the past, actually, you can see at what day, what time people mostly have coming into the, let's say, in your e-commerce or on the site or something like that. So you will put those important ads or something like that over there, and then you will see how they are reacting, and what you are getting from that ads. So this kind of decisions actually take they actually try to see pattern in the data from the previous, and they do this kind of analysis, and they will give you to some kind of options that this we can do, which will change this kind of this can change, or like bring some kind of changes into the organization, or like depending on what kind of a cost function for them, like what they want to basically increase revenue, or like more hits on the website, or like whatever it is, depending on the context. So they actually do this lot, like analysis, visualization. They create a lot of reports. Like it also happens like reporting is also one of the like very I'd say continuous job in mostly into the financial organization. Like you will see there are people who basically they open their tools, and they basically run everything like what they have, like kind of analysis, and they always generate. So these things can be automated as well, but since a business context changes all time to time, so they have to change their thing. But their main goal is this only: get the data, find insight from the data, what can we remove, what can we add, these decisions. So they actually help in making decisions, what you want to do. So this in the data analyst, if you see what are the like skills required, is mostly, of course, you need the SQL and all. You have to fetch the data from the any kind of database, and you have to actually put into like you have to do the analysis. Then either if you're using the Python, so you have to be familiar with the different kind of Python visualization tools. And then there is other tools like the very famous is Tableau, Power BI, and other stuff. So you have to have very, very good understanding of those things. So here, if you don't do, like, if you don't have the knowledge of that much programming skills, I was talking about like data structures and algorithms. It's fine. Like that's completely here. You'll mostly find logical questions mostly into the SQL. Okay, like how you can get this data with the most, how much the complicated SQL commands, that you have to know all those things. So they here actually you need to have very good understanding of database and the queries, actually very complex queries, and how you can then once you get the data, then how you can visualize that, Power BI, Tableau. And I think Tableau is quite famous. They have community also, like where people post their things. So it rank actually your skills into the public, how much you are doing. People will, I think it's kind of, I have just visited once, I think there when we are looking for one of the data analyst. Yeah, but and also like there you can, with those tools you can also create also like the kind of a like a tool, just with a few clicks, when you connect everything with a database, you can actually see the visualization happening automatically. Like for the sales, let's say for example the sales you want to see, so you can just select the area, region, and date, and it will show you the graph how it is going on. And one more important skill, which somehow I don't know how, but I forgot to talk about, is the Excel here. Excel is widely used, still heavily used. So in most into the financial organization, and also in the e-commerce we had something. So you get something with CSV or anything, XLS, any file. So yeah, Excel is still being used. So yeah, if you can learn that, that's also good. Like yeah, from there you can start into the data analyst role. They mostly do the analysis, cleaning their data, preparation, and all. And here in the programming language, this is R. MATLAB is not that much widely used. It's mostly into the academia. But R and Python is quite, I would say, important. And some of the organization data analyst, just the analyst role, they also do the modeling. So it really depends on like which organization or like which company you are like working on. It depends on the what kind of tag they give you. But as an analyst, you have to do these things. So you can't really expect that as an analyst you will get more to work into the modeling and other stuff. So if you are lucky, you will definitely get it. So if you are interested, might they gave you some kind of a modeling project, but it's more about like finding the insights here. So that's about the data analyst. I think these are the three important roles, mostly data science say in the industry, they provide in this way: data engineers, data scientists, and data analysts. And how I it's like, okay, if you want to like learn like how you wanna if you want to become any one of these and you want to like learn these skills, so there are many open MOOCs. I would start like go through the online courses, especially on like on Coursera or but right now like on YouTube also, like you can go or like you look for any organization which provide this kind of a training. So and then see just by yourself if it is if it is for you or not. Like just see where your interest lies and start learning these skills. But for data scientists and data engineers, I highly recommend to have a very good knowledge on programming. So this is what I want to talk about. And now it's your turn. So you guys can ask questions. So I talked about all these things, like how you can begin and what are the data science which provide you this kind of roles. Now it's up to you guys, like what you actually want to, anything you want to ask about data science, data engineering, or like, and so even you can ask questions from the software engineering point of view as well.
So there's one question. What are the job opportunity of being data scientist in 21st century?
If you see the figures, you'll be very happy to like you will be very happy to see those figures, like how they are predicting, like the curve, like in 2025, 2026, you will have this kind of the job opportunity. It's always growing, but it really changes over the time period, because now we have something called auto ML and a lot of things. So the title may remain the same, but work might change a bit of it. But there is always an opportunity. Like you can say data is a growing entity. It's like every second, if you see like how much data we are generating, so and in the next few years definitely it will grow, and it's a growing feeling. You have to have people to manage this kind of data to get the insight. But right now, if you see the challenges, like on social media, it is mostly the fake news. There's a few challenges which I'd like to talk about. In social media, it's a fake news one, and in the e-commerce, you have to build better search and recommendation ranking systems. Financial organizations try to understand your problem, what kind of problem you are facing, especially when you actually going to close the account or anything. So they are trying to understand this human behavior. uh, Mostly the product companies, which they, let's say, take any manufacturing product company, let's say in the beauty industry, so they want to understand how they are behaving, how their customers are behaving. They are posting reviews on the on e-commerce or any forums, so they try to understand from there, and it's constantly growing, and they try to improve their product. So they need people to analyze this kind of data, build models. So definitely the opportunity is there.
Yes, so one more question. Data scientist and data analyst, which one is better?
It really depends on like on you. It's I really can't that will be too biased answer if I'll give. That really depends on you, what you like. Actually, if you just like exploring the data, you are very curious, you can figure out the patterns in the data. If you like puzzles, definitely, like it's more of a puzzle. Like you have to figure out, you have to actually uh, answer these questions from the data, which data would be very, very messy. I'll say in the real world, it's a very messy data. If you see, you'll be like, okay, what is this? And there are many techniques to figure out the patterns in the data. And if you're very curious in doing this, definitely you're going to love that part. And if you are like very interested in building, predictive modeling, you want to automate, automate in terms of like taking decision automation, I'd say, predicting something, categorizing something. You love the deep learning things. Like if you want to work on text, images, building there are so many like applications of that in medicine, in everywhere. Wherever the data is, you can utilize these skills. But analyst is like most of finding questions, answers actually to the questions lying in the data. Like you have to find those patterns. And deep learning, what does, like the other machine learning, what it does, it actually automatically find pattern through the algorithms. But this is more on a high level, and it's more on the high level. You'll see the data, you'll figure out some kind of pattern, and you talk to your stakeholders, and then bring the changes in the organization. So like that.
So one more question. What are the difference between supervised and unsupervised learning?
So in the supervised learning, when you give feed any data to the algorithm, where there you have the labels actually given, like this is this, For example, let's say if we have to classify cats and dogs and you pass through a neural network. So while training, you give that this is a cat image and output is also this cat. And actually algorithm try to learn from there. And in the unsupervised, you really don't have the labels. Those labels you don't have. You just have data. Let's say one folder and there you have like thousands of images, but you really don't know what is what. So without labels.
So one more question. What are the common challenges for data scientists?
Yeah, there are a lot of challenges, and the most common is to actually understand the business problem. And whenever you try to solve it, it's really, so if you understand the problem very well, mostly it's the communication. If you are very good in that, if you can communicate very well, you can actually solve the problem. And having that thought that not only deep learning models or deep learning methods or like the simpler models. So mostly what happens, we directly jump into the SOTA algorithms, state of the art. And well, it can solve your problem, but there are other methods also, like with simpler models, they can also actually solve the problem. So making those decisions, I would say like feature engineering, data collection. Yeah, these are the few challenges. Like if you talk about in the technical terms, I would say preparing the data, like, having those data, preparing it, like how a model actually looking for the inputs, that data preparation takes actually quite a while, quite a time, quite long. And it's very difficult, to have those things. You have to create even tools, smaller tools to, have that labeling tool and all. So actually label data is very less in the industry. You'll just have like some few thousands, or like it's very difficult to have the label data. And mostly the data science is like or like deep learning data scientists, mostly they actually love to work with a gold standard data set, like where you have the like the data and the labels, and it's way easier to just train a model. But preparing those data sets are quite hard, I'd say. First is like understanding the business problem. Once you understand that, then you look for the data, and then you can just train it. You can do a lot of experimentation on that.
Sir, another question. How to manage data in mobile?
I didn't get the question, like how to manage data
Manage
in
data
mobile.
in mobile.
Mobile.
Yes, sir, mobile.
Well, I don't understand. If you are talking about the privacy thing, I think the big companies have already started working on the differential privacy. So it actually doesn't take data from your device. It does few calculation on that only, and this gives back something which is like not your data, but like kind of a weights of the models, which is required to train the model. So
Yes, sir. So another question from an education student. How can I become a data scientist in a near future? And what are the courses that I need to take?
yes, so first of all, you have to have the good command over the programming language. Second is definitely learn through go through some mathematics. Like I would highly recommend the Andrea Inc. Course on the Coursera machine learning. You go through it. That will give you quite give impression of how machine learning, classical machine learning algorithms work. That's the first one. And once you understand to play with those kind of algorithms, with the different kind of data sets, and once you are confident enough, then you can move forward to deep learning. And in deep learning, you can choose like either you want to start directly with text, or like images, or like audio, any kind of data. So yeah, this is on the very abstract. So this is how you have to actually go. First, learn the programming language, get comfortable with the algorithms, data structures, few things, and then start with the Andrew Ang machine learning course on the Coursera. It's very famous. You will see the basic algorithms. You will actually learn the fundamentals of machine learning. What is bias, variance, what even the like what is the data set, how you split it, and why you split in that way. There are like a lot of different techniques which actually required in in modeling. So you learn all those things, try to implement, try to play with that, and go on Kaggle. Kaggle is the amazing platform. You can choose any data set. You can practice over there classical machine learning or like deep learning, anything. Like you have and you also have a very good community over there. You can post your questions. People will answer over there. So the first is like understand these things from Coursera. Any course you take it from there, and then go to the Kaggle. I mean, for learning you can see Coursera. For practicing you can go on Kaggle. and you have everything over there in Kaggle. You even the notebook, you don't have to install anything on your system. So
So another question, what software tool and technique used in data scientist
what software and tools?
and techniques used in data scientist?
Well, the programming language, either you can use Python. Julia is getting famous, uh, but techniques is like really depends on what kind of problem you're solving. It's very hard to generalize the technique. The main thing is get the data, collect the data, then see like the problem you're solving. If unsupervised or supervised, then you split the data basically. Then you do, like before splitting, you do the EDA and try to understand what is the, if the imbalance or not, and then you will basically prepare the data set, do the feature engineering. Once you do that, like feature engineering, it's easy to like understanding the tabular data, but like let's say if you're in a working on the text or like any computer vision, so you have to basically to create more and more data, because deep learning models are actually data hungry. They need only two things: one is computing power, and there is data, as much as data you can provide. So if there is an imbalance here, but if you still want to create, or you have, let's say, a very small data set and just few hundred examples, that's the transfer learning that will not going to, that might work, but not very, that model will not be too generic or generalizable. So you have to create more data, so you can have the augmentation, image augmentation, text augmentation. You can, there are different techniques to do that. And once you have this, when you train the model, you can have different, like depending on, of course, on the labels and all, you can do to find the robustness of the model. You can have this cross validation, then testing it. Once you have done this, you're fixed on a model, then you have to productionize that model. You have to bring that, create an API, or like however it is going to consume, dockerize it, put it on the Kubernetes clusters. That actually becomes the ML ops. But some, like in most of the companies, actually you have to put the models into the production, so they expect to know these things, how to make scalable API and all. So yeah, these are the general, I would say, but it really depends on the business problem you're trying to solve.
Yes, sir. So one more question. The
Mhm.
artificial intelligence has an important role in data analysis, but my question is there data artificial stability? What are its laws? Experience of five monkey.
Well, I think I'm not aware of the law which you are asking, but the artificial intelligence is a different word. I think you are, it's, you're mixing two different things. Artificial intelligence is a broad, it's a system. It's a very big, it's a different thing. And data science and everything comes under like AI, data science, machine learning, deep learning. This comes. So usually artificial intelligence is considered, could be a big system where deep learning and machine learning, they are the parts actually. So it's two different things. Okay. So one thing, like the biasness comes, like if you talk about the artificial stupidity, it's really depend, like you will see the biasness in even Google search. You can find the biasness, and it really depends on like what kind of data they have been trained on. There was very famous, I'd say, case when Amazon, I think it's from Amazon, when they created a model for the applications for recruiting something. They were, and that model was actually biased against female candidates. I'm not very like sure. I just read it from somewhere. You have to go, dig deep, and so that's really depend, like the what different kind of data you have given over there. So algorithms they become biased very easily. So those things you have to take care of that. Every variable you put through the algorithm to learn, you have to take care of that. Like you have really given enough examples so that model is generalized and not getting biased towards any of the labels. So that's very important. And it's also difficult to manage those things, especially when you work with like categorical features. uh, uh, well, I can talk about this in more detail, but yeah, would be reading a different session. So wherever, like when we actually code and we see the model, so I can show you, okay, how it is getting biased and how you, what are the treatments for that. You can use that. Yeah, but in a nutshell, they get biased towards it, and very easily, actually, I'd say very easily get machine learning algorithms or deep learning algorithms, they get biased towards any of the category. So I have to take care of that.
So thank you so much, sir, for making our doubt clear. The webinar was really very amazing. I would like I would really like to propose hearty vote of thanks to you, sir, for gracing today's webinar, and your presence, your wise word help magnifying our cause in best possible ways. I hope all the participants learn a lot with this webinar, and I would really like to thank you, sir, for giving us your valuable time. And I'm also be delighted to be a part of this webinar. So
Thank
thank
you
you
very
so much.
much. Thanks a lot for giving me this opportunity to speak. Yeah, thanks a lot. Any questions, you can connect yeah, later. Or like anybody, if you have anything, maybe you can connect me on LinkedIn or like, yeah, I'd be happy to help. That's
A good event never end in a world. They take only a pause and keep us awaiting for the next. All good things eventually end. I consider everyone as fortunate that they become a part of this webinar, which was full of knowledge and which made difficult to say goodbye. And remember, don't forget to subscribe our YouTube channel and tag us on Instagram like hashtag Digisaksham along with the screenshot in your story. So thank you so much guys for cooperating. And again, thank you all for attending today's webinar. And if you have additional question, you can contact us by email or telephone. We are happy to provide you additional support. The end of one chapter is the beginning of the next. So keep on reading, the best is yet to come. I, Kanikagar, your host for a day, sign off on a cheerful note. Have a wonderful day. Thank you.
bye bye, everyone.